Okay, as promised, I'm going to do the video of the 40 questions. Don't look at me. I told you do your work. When are you making up that test? All right, anyway. Um, so, sorry. Okay, so I'll get rid of my fat head here in a minute, but I said I'd do, and thank you, whoever Valente is. You made this practice exam that we stole off the internet at Lockport High School, and then use that as a practice test in many of our classes, and I definitely did in mine. I told my kids I'd video how to do them after we finished. So here we go. I'm going to do all 40 in a row and hopefully be done. I'm already into this pretty good, but hopefully be done in 20 minutes for 40 questions. You can pause and look at my work and re-listen to me as I go through them. Okay, enough. Okay, first thing we got to know on this one. Number one, if I were to FOIL this out, you would have a negative x to the fourth. I can't really explain that. You got to be able to figure that out. Next thing is polynomial dance. Okay, we do the polynomial dance. X, y equals negative x squared, negative x squared, x to the third, negative x to the third. Then the kids go nuts and they dance like this and so on and so forth. But that is what's going on now. That's the only reason I had to have my face up there. Okay, but that's what a negative x to the fourth would do as far as then behavior looks. When you put that with the zeros together, boing, this is a bouncing zero here. This is what the graph would be. And an input, say it, my class always says output. That can solve so many different things. That means these are all positive outputs and zero as an output. So that would solve this equation. That means if I plugged in negative 2 into this, I'd get a positive output, which is greater than 0. That's too much explaining. That's why that happens. Next one. Okay, we know what average rate of change is. It's just slope. So the chart input output shows 2 comma 1, 5 comma 11. That's slope formula. Y2 minus y1 over x2 minus x1. Next. Logarithm rules. This is just the division rule. So log base 4 of division means subtract these two logarithms. I don't know if I'm saying that mathematically perfect, but that's what happens. Oh, and then lo and behold over here, I tried to explain this. 2 is actually equal 4 to the half power, because that means square root of 4. Really can't explain it any further. We need to know that. And then I could pull that half out just like I pull this 4 out in front. And then log base 4 of 4 is 1. 4 to what power equals 4? 1. So that's how we end up getting that answer. Next. That's why this is going to go fast. Again, thank you, thank you, thank you, thank you. I have this on every page just in case one of your students finds this video and said, hey, someone stole your test. All right. It was out on the internet, so we just grabbed it and used it. Okay, this is the sine sum rule. Sine cosine plus sine cosine. So yes, you're going to have these identities memorized. All right, nothing to explain there. Then cosine of 2 pi over 3, that's in quadrant 2. And then that's the negative 1/2 as a ratio. And I'm not going to spend time covering how to get these ratios from the unit circle. Sine of 2 pi over 3 is the root 3 over 2. 2 pi over 3 is in quadrant 2. So sine's positive, cosine's negative. All right. And I don't know what else we can do in getting these memorized. I know many of my students do. Many of my students don't. And I don't know what I can do for them. I had a lot of buildup to get that figured out. Anyway, all right, let me just make sure. I did these today, but I just got to remember and collect my brain as we get going on this. Okay, so table, so which of the following claims? Okay, so it's trying to say, is it linear or quadratic? Okay, this is first or second order differences. First order differences are not the same. If they were, that'd be linear. Um, and then that would be this one. F is a linear function because the average rates of change over consecutive equal length, and yeah, blah, 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 are constant. They're not. So the second order differences are equal. When I do this again, these are all negative 3 away from each other. So it's quadratic because the difference in the average rates of change, which actually denotes second order differences. So you got to remember that. This is stating a first order difference when you just say the average rates of change. The differences, because the differences in average rate of change over, because average rate of change over can say the differences in average rate of change. There you go. That's the differences of the average rate of changes. That's the second tier. All right, sorry. They got those words in there. You know how AP goes. Pretty tough. Hey, here we go again. And behavior again. And we're in that fourth one here again. Little tricky, though. This does mean this is a negative x to the fourth. So if I FOIL this out, of course, this would be x to the fourth times negative zero point 0.5. But here's the kicker. The y-intercept would be negative 4 times 1, negative 4, but then negative zero point 0.5 times that. So that gives me a y-intercept of 2, because this one is also a negative x to the fourth. If I FOIL this, this would be x squared minus 4x plus 4. This would be x squared plus 4x plus 4. Good FOILers, good factors, but good foiling there. And then x squared times x squared is x to the fourth times negative zero point 0.5. Ultimately, this would be 4, and this would be 4. 4 times 4, 16. Then negative half of that, negative 8 would be the y-intercept for this graph. Just denoting why it is not D and what the difference between C and D is there. All right, so make sure we understand that. All right, holes. Just to go over this real quick, you factor and then you cancel. That's why there is a hole at 3 comma 3 comma what? Well, then what do you do next is you plug in 3 into the leftover equation. And then that is where the hole is located, where the interruption in the graph is located. So yes, f of 3 is undefined, but then it is a limit thing approaching. When you approach 1, 2, 3 from the left and from the right, then the y value that you're approaching is, well, 2, because when I plug that in, I get 2 for an output value after I cancel the x minus 3's. So that's why this is the correct answer. All right, next. We did do that a lot, but boy, that was a long time ago. All right, so this right here means even. When you plug in negative for x and you get no change, then that means you are an even function. So that means if f of 3 equals negative 5, f of negative 3 should equal the same thing. By the way, I thought just for giggles, odd, if you plug in negative x, the opposite would occur. So if f of 3 equaled negative 5 and it was an odd function, f of negative 3 would equal the opposite of negative 5, which is 5. So it's an even, and therefore that's why this is true. All right, and then that last one, if they said it was odd, or if they said f of negative x equals negative f of x, then this would be true. The opposite of x produces the opposite of y. But it doesn't, so that's not the answer. Just giving you some more. All right, and then end behavior here. This is what this graph does. Input, say it. You plug in 0 for x, you get 1 times 3/4. And then as you plug in bigger numbers for x, these y's get smaller and smaller. As you plug in negatives, that flips this fraction and makes the outputs larger. So that's why this limit statement is the true one, highlighted by, with those arrows in the limit statements. Next, this is that alternative form section. So read that question again. 5 to the x plus 2 comes from 5 to the x times 5 to the second. Because what are you supposed to do with these exponents going in reverse? Add them, right? So that's the exponent rule. We're just going in reverse and reversing that rule that we know. And then that means 5 squared is 25. It actually can be considered a dilation factor compared to this other form. So I don't know. We did quite a bit of that. It just was a while ago. All right, this one's kind of weird. All right, and what we got to remember is it says which one does not have a slant asymptote. You get slant asymptotes when the degree of the numerator is bigger than the denominator. So f of x is x cubed, g of x is x squared. This has a slant asymptote. So does this. So does this. And then what I had to do is kind of plug this one in just to see. If I FOIL this, x squared times x, degree 3. This is x squared minus 10 times x minus 1 would be a degree 3 and x cubed. These are equal, and actually, I told you even more information. Hopefully you remember your horizontal asymptote rules. If I FOIL this out, this would be 1x cubed, and then the bottom would be 1x cubed. So y equals 1 is a horizontal asymptote. Better know that as well. Blah, blah, blah. Okay, next one. Actually, this is and we actually luckily we had another test that we did in class on the AP multiple choice college board website, and I was able to put this up here, and this rule came up. And then on your test, thank you by the way. Here it is. Thank you. Um, but yeah, it's this rule: two raised to the log base 2 of x is x. 7 raised to the log base 7 of x is x, as long as these are equal. E raised to the log base e of x, which is ln x. Then I even did a calculation real quick. E raised to the ln of who cares? I brought up 134. Look at the calculator even spits out 134. So when we do this f of g of, I have my highlighting to show that. Ln of x is g of x. And then f of that means wherever there's an x in f of x, I replace that with that blue, right? But I had to highlight it yellow there to show that replacement. Then this 2 becomes an exponent on 4x. That's our exponent rule. Power raised to a power is really the name of that rule. And then e raised to the ln of whatever is whatever. And then you distribute that squaring, just like e raised to the ln of whatever is whatever, 134. So that's how these cancel each other, I guess, in a way, mathematically. So that's why that simplifies to b. All right, maybe too long of an explanation on that. Super fast on this. Negative 4 comma 5 pi over 6. 5 pi over 6 is in quadrant 2, but negative 4, you do the 180 graph of that. Well, this angle right here is directly negative pi over 6. 4 comma that lands right in that same spot. Nothing more to explain. Next one, input, say it. My class always says output unless they're licking the walls. Anyway, input output, when I plug in 1 for x, 3 to what power equals 1, the answer is 0. When I plug in 3 for x, log base 3 of 3, 3 to what power equals 3, 1. So that's what these are, these evaluations. Then what it says is the inverse of this. When I say inverse, you say switch x and y, all right? Unless you're licking the walls again. And then you resolve for x by changing a logarithm to an exponent. So there's the inverse of this graph. Okay, best way I can think of it, all right? It's a log graph, so it should definitely be an exponential answer. All right, oh, this one's so tough. Okay, so this is what I did. When I say inverse, you say switch x and y. So I wrote these down. What is this, helium? He? I'm just kidding. I think that's a symbol for helium from science. But what I tried to do is read this question. F, the input of F are heights in meters, so heights, He, and the outputs are atomic pressure, so atomic pressure. When I take the inverse of this, that just switches those two. I thought this was a smart way of approaching this. May be wrong, but I think I'm right. Well, I know I'm right that this is what happens. I think this helps us get this answer. G of x then is temperatures input, temperatures, TE, in degrees Celsius. Output values are heights again, HE in meters. When I find the inverse of this, I switch these. So then they ask, what is the inverse of G of the inverse of X represent? Well, what I did is the inverse of F of X, the X value or the input value is A of T. So A of T, let me see, is atomic pressure. That's the input. So, and then the output is inverse of G of all of this, which is the Y of inverse of G of X, which is the temperature. So temperature, the output, as a function of atomic pressure, the input. Tough. Had a real hard time with that. I had to like kind of do what I know, which is inverse. When I say inverse, you say not outverse. Switch X and Y. All right, and then that made it make sense. Okay, tough, tough, tough. Okay, this one should not have been divide by 2, and then so okay, and you know how this works. Again, I haven't seen these in a while, but f of x equals this, and f of x equals root 2. So just do a substitution. So root 2 equals 2 cosine x, then divide. Okay, come on. We got an over 4 here for root 2 over 2 as a ratio in our unit circle. And I thought I'd put ASTC for quadrants of where cosine's positive. All right, moving on. Logarithmic function, log base A, log base 2b of x. And then they give us limits. So I really got to read this. As x approaches negative infinity, that's going this way. Y approaches infinity. So that means the logarithmic function goes this way. That's its behavior. And I'll get rid of those. And then x arrow 0 negative, that means you're just to the left of there. As I plug in x's this direction all the way up to the y-axis, the outputs are going to negative infinity. So that's why this is the picture I have here. So the only way this could happen is if A was positive, but B was negative because that represents a y-axis reflection. Okay, so that's why it's letter C. Got to move on. These are things that we unfortunately need to have memorized, I would say. Which of the following have no real solution? Basically, you can't take 9 to a power and get a negative number. And no, 9 to the negative second does not equal, what the heck just happened there? Negative 81. It equals 1 over 81 through the flipping rule. So all the other ones have answers, which I showed. This just means decimal. We'd have to use a logarithm to find that. Okay, thanks again. Okay, just want to give you credit if you're watching this, Mr. or Mrs. Valente. I don't know who made this. All right, and this is a video I used to describe what a radian is. And they showed the peeling off of this radius to put that length here, and it ended right around there. Then when you drew this ray here, this represented 1 radian. Then when you slapped another radius on here, and then we did this, that represented 2 radians, and so on and so on and so forth. So yeah, we had that video that was real nice. So when you read this question, this is 5 comma 0, so that means 5, 10. This is 2 radians from here to here, right? And they do have this listed in here. So if the arc is 10 units, that's why I put 5 and 5. All right. Again, based off of knowledge here. Oh, brother. They had to bring up the semi-log plot. If you remember the semi-log plot, what it does is it takes an exponential that's graphed in a regular coordinate plane, 0, 10, 20, 30, 40, and then scales it into factors of 10. So here's from 0 to 10, and then notice how these are not equally spaced. And then the next equal interval goes from 10 to 100, which is not equal, like spaces going by ones. That's the point of a semi-log plot. What it does is it takes exponential data and turns it into linear, and then we're able to see the numbers on a grander scale, I guess, but see it on a nice plot and it looks linear. So that's the whole point of a semi-log plot. Nothing really else to say on that. Tough remembrance. That was the end of our semester, first semester, I believe. Okay, sinusoidal. Relative max at 1 comma 2. Relative min at 3 comma negative 6. So that's how I started my graph. I connected those two. That means this is a distance of 2 units. So another 2 units, I'd complete this, what would be a cosine curve, what I'm looking at from right here. Because from 1 to 3, I got half of a cycle done. We should know that. By the way, 1 to 3 to 5, 1, 2 is where a 0 would be located, but that's actually down 2 because of the average of 2 and negative 6. We'd be at negative 2 where the midline is. So the reason we need that is some truths. Function has a y-intercept at negative 2. That's true. We'd have to go backwards on this graph to get that. Relative maximum at 5 comma 2. We'd have to go forwards on this graph. Function does have a period of 4 because it is 4 units from 1 to 5 that this picture is done. Amplitude is actually 4. Is it 4? Hold on. Negative 2, 1, 0, 1, 2. Yeah, okay, 4 up and 4 down. My bad, dogs. Didn't count that ahead of time. All right. Okay. So sorry, Valente. I think you put C as an answer, but we think it's B. If you're watching, he's not, or she. But this is what a residual plot is. When the actual minus the predicted, that's the residual. So the actual minus the what the model says. So the actual is higher than what the model says. So the model is an underestimate because the residual is positive. All right. So we had this from our notes here, just as a reminder. Tough vocab. Okay, another tough one for my class, especially the memorization of our identities, which they have to be memorized. Unfortunately, for cosine of 2 theta, it's because of the Pythagorean identities. I could plug in 1 minus sine squared for cosine squared and get this, or I can plug in 1 minus cosine squared for this and get this one. But when I look at this, it's this first one that's being used. So what's g of 7 or g of pi over 7? When I plug in pi over 7 here, that becomes pi over 7 in the identity. 2 times pi over 7, that means 2 times pi over 7, that means x is pi over 7. Okay, just knowing how the argument works there. Another sine graph, by the way, I did a sketch of 2 sine x, up 2, down 2, 0 to 2 pi, high point at pi over 2, low point at 3 pi over 2, pi is a 0. But then it says, where is f of x greater than 1? This is how we did it one way. 1 is here. We need to find these x-intercepts here. Wrong. These x values, input say it, they give me outputs of 1 that shows where the graph is greater than that. Again, input, output. I want these x's that create these outputs that are higher than 1. All right? And actually, I just know what they are. Sine of pi over 6 is a half. Half of 2 is 1. Sine of 5 pi over 6 is a half as well. That's the quadrant 2 over 6. Half of 2 is 1. So though that's pi over 6 and that's 5 pi over 6, it's every x in between there that gives me outputs greater than that. All right. Oof, we're moving along, and hopefully I might be at 40 minutes. These feel like they're taking a little bit lengthier. Okay, but the point 1 comma negative 3, you're a fool if you don't graph this. 1 comma negative pi over 3, you're in quadrant 4. That instantly destroys that answer and that answer because those two angles are not in quadrant 4. Tried to impart this on my students in class, and some do it and some just don't get the simplicity of some of these questions. Okay, so then I'm down to these two. Well, I knew right away when this was root 3, that's opposite of 60. 60s are over 3s. I'm done. But if you needed to do this, this is the formula to get what r is, Pythagorean theorem, and then this is the formula to get theta, inverse tangent. This is no calculator, though, so you still need to know that this is where a 60 occurs, which is an over 3. I don't know what else I can tell on the unit circle. We just got to know it. And then I made a note to myself that I wanted to graph tan while you guys were watching this. But this is flat out a definition of cotan. Because here's what tan looks like. Tan, the period is pi, and you go half a period left of the origin and right of the origin to draw the asymptotes. Because tan of 0 is 0. Tan of pi over 2 is undefined. There's another reason. Tan of pi over 4 and negative pi over 4 are 1 and negative 1. I don't know if I said that respectively or not, but I marked them correctly. So that's what the tan graph looks like. I thought I would throw that in there along with the cotan, but I don't know. I should be done talking about this. Either know the cotan graph or not. And I think that ends wrong. We get 2 more. Okay, and I did an input-output on this, but really some of these fall out of play. So a rose, when they're odd amount of petals, this has got to be 3s in the argument position. So really those are gone. And then the difference between a cosine and a sine rose, a cosine rose, whether it be positive or negative, has their rows on an x-axis, either this one or that one. And I want to call it an x-axis compared to rectangular graphs, but someone might not like that I said that. So I knew this was a sine right away. If it was a negative 4 sine 3 theta, I might have a problem. I thought maybe this rose might be up here. So I did a little input-output. Hey, here's pi over 2. Pi over 2 is up here. When I plug it in, that turns it into 3 pi over 2. Sine of 3 pi over 2 is negative 1. So when I plug in pi over 2, I get negative 4. Okay, input-output, that matches that point. So I feel really good about A. But all the other reasons, It was A because of elimination of all the other not possible scenarios. Okay, so this 28, f of 2 equals 0 and f of 6 equals 0 just means that polynomial has x-intercepts here. Whoops. So one of two things could be occurring here. You hit the back button here. There we go. You could either have this green curve going through these, or there could be more x-intercepts in here. There could be a little bit of a loopage in there, but I'm just doing the minimum. Or there could be this loop of the polynomial, red or green. So this first letter could be A if it depends on the polynomial. It could be true, but it could be anything, actually, now that I think about it, because it doesn't say anything about the power or degree of the polynomial. So there's nothing to say anything about what the end behavior is going to do on this. Next thing, f of x is greater than 0 between 2 and 6 if it was the red graph, but what if it was the green graph? So that's not always true. And then f of negative 2 equals 0. That's only if the function was even, and it doesn't say anything about it being even. There's nothing to say that that would even actually occur. So what is you see in this graph is there is at least a relative max or a relative min in between these two because of the behavior of the graph through those zeros after that. So it's C. All right, I think I'm going to stop this video because I went longer than I wanted to. And then I'll separate the second one into its own. Oh, I don't even know how to get out of this. Oh, here we go.